that didn't have a whole bunch of teeth set into a jaw, but instead had protrusions of the bones.
Through natural selection and evolution, the plates that form the lower jaws have actually become thin, elongate, like cleaver blades, and you actually have several points coming up on these things. And they were essentially self-sharpening. When the lower jaws moved against the bony plates of the upper jaw, it was just like sharpening a knife.
But much of reconstructing Dunkleosteus remains an act of imagination.
When we're trying to reconstruct an animal like Dunkleosteus here, the only thing you have to work with is the actual skeleton. We have to imagine what the eyes would look like in the eye socket, what sort of covering would there be over the plates that form the teeth, and what sort of skin would be over this body. As a paleontologist, what we want to do is draw modern analogs. When we're looking at things like placoderms, this is a whole group of vertebrates that went extinct. There are no modern analogs to this.
Though armored fish no longer exist, Dunkleosteus's closest living relatives are sharks.
If you can use some kind of modern animal to say something about any kind of behavior, because it truly is speculation. I mean, the suspects are dead.
Essentially what geologists and paleontologists are doing is we're all trying to figure out the plot of the same movie. But that movie has been cut into frames, and those frames have been scattered outside and left out in the weather for hundreds of millions of years. When you go to a geological formation, you have one frame of that movie, and another scientist somewhere else in the world may have the next frame. And then from those individual snippets, you have to try to reconstruct the history of life on Earth with a lot of time missing.
Given nature's incessant predator-prey storyline, the plot often revolves around a murder mystery, as it does in